In this next lesson, we're going to get a little bit more general with our graphs. Now, we're going to kind of look into something a little bit different than we worked on when we talked about vertical asymptotes and horizontal asymptotes. We've always had the understanding that vertical asymptotes you cannot cross over a vertical asymptote because that's where the function is undefined. Now, we get a little bit more specific, and there is a possibility that when we graph some of these, you will be able to draw a function that goes through the horizontal asymptote. Because when we talk about the horizontal asymptote, we talk about an end behavior. So what is happening to the graph as you go to negative infinity to infinity? So we're talking about the extremes of the actual function. So our little graph that we're going to be looking at is not the end behavior necessarily. So it is possible in these next graphs, next couple graphs, that we will see functions that cross through a horizontal asymptote. So don't be alarmed when this happens, in fact will. So just keep in mind that it's talking about end behavior, not the small little picture that we see. However, vertical asymptotes you indeed cannot cross through because that's where your function's undefined. So that being said, let's go ahead, and once we get through some of these examples, I think you'll understand it a little bit better. So we have p of x and q of x, no common factors other than 1. So here we have the graph, and we're dividing them. This is just general notation. The thing that you need to be cautious of or think about is this m value, which is the degree of the numerator. So m is the degree of the numerator. You might want to jot that down. And n is the degree of the denominator. So when we find out these different asymptotes, they will talk about the m and the n, and just to give you an idea. So this is a chart that you're going to have to memorize. So you have m is less than n. So if the degree of the numerator is less than the degree of the denominator, the line y equals 0 is your horizontal asymptote. If the degree of the denominator and the numerator are equal to each other, then you simply just divide out your coefficients, which is what we actually did in the lesson from yesterday. And then we have m is greater than n, so if the degree of the numerator is bigger than the degree of the denominator, then you actually have no horizontal asymptote. So it does not exist. So let's take a look at this first example. So the vertical asymptote, again, still found the same way by taking your denominator and setting it equal to 0. So x minus 4 equals 0. So your vertical asymptote in this case would be x equals 4. Now the horizontal asymptote, we have to pick out the degrees. So your m value is just 2 because that's the degree of the numerator. And the n value is 1 because it's x to the first in the denominator. So we have m is 2, n is 1, and then we have to take a look at the graph. So our m value is greater than your n value. M is greater than n. So this graph has no horizontal asymptote. So you would write none or does not exist. The x-intercept, again, still found the same way by setting x or y equal to 0. Cross multiplying and solving, so you get 0 equals x squared minus 9, and you can factor this into x plus 3 and x minus 3. So your two x-intercepts in this case would be negative 3, 0, and positive 3, 0. And the y-intercept, again, same way that we've done it before, is to set x equal to 0. So in the numerator you'll have 0 squared minus 9 and 0 minus 4 in the denominator. So we'll end up with negative 4 divided by negative 9, or simply a y-intercept of 9/4. For this next problem, the vertical asymptote, again setting the denominator equal to 0, we're going to have to factor this in order to set it equal to 0. So this in order to solve it. So when you factor it, you get x minus 3 times x plus 2, nope, x plus 1 is equal to 0. So your vertical asymptotes we will actually have 2 in this case. So x equals 3 is a vertical asymptote, and x equals -1. The horizontal asymptote, we have to pick out our m and our n. So m would represent the degree of the numerator, and the numerator is just x to the first, so the degree is just 1. And n is the degree of the denominator, which is x to the second, so 2 is your n value. And now we look at that chart that we wrote up above. Our m value is less than our n value. So m is less than n. The line y equals 0 is the horizontal asymptote. So when we write that down, we'll just write for the horizontal asymptote y equals 0. The x-intercept, I'm going to go ahead and set that equal to 0. And then cross multiply. So you'll get 0 equals x plus 3 when you cross multiply. Subtract 3, your x-intercept would be -3, 0. And then the last one is your y-intercept, which is when you set x equal to 0. So we'll have 0 plus 3 divided by 0 squared minus 2 times 0 minus 3. Simplifying that, we get 3 divided by -3, which is -1 for the y-intercept. For this next problem, number 3, I'm going to go ahead and have you pause the video and attempt to do the 4 different things that you see in front of you on your own. I'm going to go ahead and write them in, and when you come back after you unpause it, you should see the answers, and just double check to make sure that you have the correct answers. If you don't, just go ahead and make a mark and make sure you ask about it tomorrow. So you want to pause the video, and when you come back, you hit play again. It should be when your answers are done. So now you see what I have for number 3. I have the vertical asymptotes as being x equals -2 or -3 and x equals 3. The horizontal asymptote I have listed as y equals 0. The x-intercept is 0, 0. Now, of course, I didn't technically have to do the algebra down here to find the y-intercept, because if the x-intercept is 0, 0, the y-intercept has to be 0, 0, but I did it just to double check. For number 4, I'm going to have you do the same thing. The only one I'm going to go through with you after you're done is the horizontal asymptote. So go ahead and figure out the vertical asymptote. There will be 2 of them actually. The x-intercept and the y-intercept. And then when you come back, we'll do the horizontal together. Now here I found the vertical asymptotes for the x equals -2/3 and x equals 2. The x-intercept turned out to be, there was none. You can see my work there off to the right. So we ended up with 0 equals -1, which is not possible. And then down here for the y-intercept, I had -1/4. Now the horizontal asymptote, at first glance, it looks like it's hard to figure out the degree of the numerator. Well, here we have the number 1 in the numerator. What would be the degree? Well, technically, this would be an x to the 0 power, because remember, anything to the 0 power is 1. So we could write an x to the 0, and that gives you an m value of 0 and an n value of 2, because the degree of this denominator is 2. That was x to the 0, so it was 0. So we have an m value less than our n value. So our horizontal asymptote is y equals 0. And then the last 2 here, we're going to go ahead and, again, I'm going to have you try to do these on your own. I'm not going to walk through step by step, but pause the video, do the problems, come back, hit play, and double check your answers with mine. You'll see the answers for 5 and 6, just to kind of give you some idea. Down here for the x-intercepts, I decided to complete the square when I found my x-intercepts. You could have used the quadratic formula if you wanted to. You should have ended up with the same exact answers though. And they would be 5 plus or minus 2 squared of 5. Now for right now, we don't really care at this point if there's an approximation because we're not graphing these problems. Now in the future we will be graphing, and you would want to put this in the calculator to find that approximation so you can plot them on the x-axis. Same thing here with the y-intercept. So this would be right now you don't need decimals, and it would be appropriate to put decimals if you're trying to graph. And then over here on the right, I didn't have to use, this one was factorable for the x-intercept, so I factored to solve. And then you can go ahead and pause this, double check, make sure you have all your answers the same as mine. For the rest of these problems, we are actually going to take one step further, and we're going to go ahead and graph them. So we're going to find all the same things that we just found in the previous problems, but we're going to take that extra step and graph them and find domain and range on top of that. So for number 7, graphing y equals 6 divided by x squared plus 1, we're going to find the x-intercept first. So to find the x-intercept, I'm going to set y equal to 0 and cross multiply. So we end up with 0 equals 6, which is not possible, so therefore there is no x-intercept. The vertical asymptote, that's when you set your denominator equal to 0. So I've now added this picture, what I got from Desmos, and I have some points plotted here. You could plot more to get a general idea is really what you want to do. Now the domain for this one, again, it's just as if we've done domain and range before, the furthest left to the furthest right. So the domain for this one would be negative infinity to infinity. There is no vertical asymptote, so we don't have to worry about any kind of breaking. And the range in this case, it's not going to go below the horizontal asymptote, so your range for this one would be 0, infinity. In this next one, our x-intercept, we're going to set y equal to 0, so you end up with just 0 equals 2x squared. So your x-intercept turns out to be 0, 0, and if your x-intercept is 0, 0, that means your y-intercept has to be 0, 0. You can test it out if you like by plugging 0 in for x's, but that's what it turns out to be. The vertical asymptote, when you set your denominator equal to 0, you can factor your denominator into x plus 3 and x minus 3. So you actually have two asymptotes here, negative 3 and positive 3. And the horizontal asymptote, your m value is 2 and n is 2. So that means that your m is equal to n. So that means that you're just going to take your coefficients and divide them. So your horizontal asymptote would be 2 divided by 1, which is just simply 2. And then again, I worry about domain and range after I plot what I have. So we have two asymptotes, negative 3 and 3. So here we're going to have a couple different sections in our domain because we have 3 different sections because we have the two asymptotes. The y equals 0 was your horizontal asymptote. No, y equals 2. Zero, 0 is the x and y intercept. So this is vaguely pretty much a general idea of what your graph should look like once you put it in the graphing calculator. So let's talk about how you're going to type it in the calculator. Again, you want to make sure that you put parentheses around your denominator. So you're going to need parentheses around the binomial, the x squared minus 9, to make sure you put it in there correctly. So off to the right, you'll see the graph that I put into Desmos over here. Now the domain for this one, again, I said just a minute ago that it'll be broken into different sections. So you'll have negative infinity to this first asymptote, which is negative 3. And then we have this section in between the asymptotes, and then we have the section to the right of the x equals 3. So your domain for this one would look like this, negative infinity, comma, negative 3, union, negative 3 to 3, union 3 to infinity. Now the range for this one is a little bit different because we're not going to go up to our asymptote, because if I take a look at the graph, this little section right up in here, this highest point, this maximum point, happens to be 0, 0. I know it's 0, 0 because that was one of the, that was your x and y intercept. It's not always the case. You may have to actually calculate that min or that max. If you don't remember how to do that in your graphing calculator, please make sure that you ask somebody. It's in that calculate function. So you do actually need to figure out the highest point or the lowest point by calculating it in your calculator. In this case, I didn't need to because I can clearly see it 0, 0. So I'm going to go ahead and find my range. It's negative infinity to 0, and I can include 0 in that range because there's a point there, 0, 0. And then union, and then it doesn't start back up again until the asymptote passed beyond that. So the horizontal asymptote is 2, infinity. And this last problem, like we've done the other ones, I'm going to go ahead and ask you to pause the video and then complete this problem and come back after you're done and see whether or not you have the right answers. Now for this one, here I have my intercepts as negative 4, 0 and 1, 0. My y-intercept was 0, 2. The vertical asymptote x equals 2, and there was no horizontal asymptote. Now for this one, the domain is not going to give us a problem. The range, however, you're going to have to do a little bit of work, and I haven't quite found out how to do it on Desmos yet, so you are going to need a graphing calculator for this one. So now for the domain, again, that's restricted by that vertical asymptote, so it'll be negative infinity to 2, union 2 to infinity. Now for the range, it's going to be slightly different because if you look at my graph, by the way, if you put it in a graphing calculator, this portion up here in the far right will actually not show up in your graphing calculator because the window is too small. Now in Desmos, here you can see that this all these points are above 12 on the y-axis. So you are going to have to zoom out or change your window in your graphing calculator. So don't forget when you hit the zoom, the button for zoom and the number 3 for out, you do have to hit enter to execute that zoom out. So when you're going to do this, you have to calculate this point. That's a maximum down here in this little shape down here that kind of looks like a sideways parabola. But so you have to figure out this top point. You can't just assume that what you see is here. Same thing, I'm going to have to calculate this minimum point. Now you may remember to find the minimum point, you go into calculate, and this time I'm going to work on this lower one. I'm going to hit the maximum, which is number 4, and it's going to ask you to choose the left bound and the right bound, so you're going to move the cursor to the left and the right of this point, and then hit enter. And I'm getting a maximum point of 2.1 approximately. So my range would be negative infinity to 2.1. That's the highest point, and it does include 2.1 because that's a maximum. It's actually a point. So this point right up here, the y value of the highest point is 2.1. And I'm going to do the same thing down up at this far right corner, and I'm going to calculate the minimum point. So you go to calculate, you're going to choose number 3 for minimum. You're going to have to move the cursor over. And I'm getting a minimum y value of 11.9. Now, of course, I rounded that 11.9. And that's going to go to infinity because it's going to go forever that direction. So a few things, make sure you know how to zoom in and out or change your window. So if you don't know how to do that in a graphing calculator, make sure that you get with somebody to understand how to do that. And if you're not quite sure how to find a maximum or a minimum, make sure you ask about that also.